Hi everyone, and welcome to this presentation about TeamMate APIs and system integration. In the next hour, we will talk about why we need a strategic approach to system integration, what APIs are and what they can be used for, and what to consider when initiating an API integration project. My name is Linda Lundin. I used to work for the Institute of Internal Auditors in several different roles, most recently as the CEO of the Swedish IA Institute. During this time, I participated in many national and international task forces and initiatives aimed at elevating the internal audit profession. As we will soon discuss, many of the challenges the internal audit profession faces needs to find its solutions in stronger system support and technological maturity. That is why I decided to join Bright after I left the IA in 2020. Bright is a consultancy firm specialized in capturing business value through technology. By combining business and IT knowledge, we provide holistic solutions in the areas of GRC, finance, IT, and business. For the internal audit proposition, we are the official partner of TeamMate in 10 different European countries. My co-speaker today is Mikael Nevelius. Mikael is a highly skilled software developer with experience from API integrations and software development at several large organizations. He's part of the Bright network, and we cooperate on projects with technical focus. Mikael, can you tell us a few words about yourself?
Thanks for the invitation and the introduction, Linda. So, a few words about myself. I started as a lawyer, but I've always had an interest in technology. Some years ago, I made the switch from law to IT, and these days I design and build software. Today, I've been asked to talk about APIs and to give some examples of common challenges in software development that I've come across, particularly in larger organizations. So, I hope I can add value to this presentation from a technical perspective. Back to you, Linda.
Thank you. By the end of this session, you will understand the utility of software integration from a strategic internal audit perspective, get a knowledge of what APIs are, and know what to focus on in order to build TeamMate integrations and software in general efficiently. Before we dive into the details, let's have a look at why internal auditors should know about system integration. There are a number of key factors driving the evolution of the internal audit profession. I'm sure you all recognize these factors from your own professional careers. What this image shows us is that there are many factors that are currently driving the rising stakeholder expectations of the internal audit profession. To meet these rising stakeholder expectations, the internal audit profession needs to carefully utilize technology. This is necessary to balance assurance activities with other assurance providers, to gain insights needed to allocate resources, and to adapt audit plans when needed, and to consolidate information in a useful way to boards, senior executives, and external stakeholders. It is needed to stay on top of new risks and new legislation. It is also needed to ensure that time spent by the internal auditors is well used and as little time as possible spent on administrative tasks. This is important in order to ensure the effectiveness of the internal audit department and to keep highly skilled professionals interested in remaining in the profession. To manage all of this, the organization, as well as the internal audit function itself, needs to adapt a technology strategy to map out the best way forward. A good way to start such a digital strategy is to go back to basics. Who is expected to do what in your organization, and what role should internal auditors have in this? I'm sure you're all familiar with the 3 lines model, updated by the IA in 2020. The purpose of this model is to help organizations identify structures and processes that best assist the achievement of objectives and facilitate strong governance and risk management. This makes it a good starting point for any strategy exercise when it comes to mapping and aligning assurance activities, including technological strategy. When the IA initiated the Relook project of the 3 lines of defense model, the goal of the project was to emphasize the importance of not only avoiding risk, which the initial name might have suggested, but also adding value from a GRC perspective. An additional goal was to open up for the possibility of greater collaboration between the lines, sometimes referred to as blurring of the lines, in order to avoid having these lines working in silos. This is also clearly stated throughout the position paper outlining the updated model. This is especially clear in the description of Principle 6, Creating and Protecting Value. It reads, "All roles working together collectively contribute to the creation and protection of value when they are aligned with each other and with the prioritized interests of stakeholders. Alignment of activities is achieved through communication, cooperation, and collaboration. This ensures the reliability, coherence, and transparency of information needed for risk-based decision-making." So, in an environment where each department works in different systems, how can communication, cooperation, and collaboration be achieved? On a high level, there are two different ways to go about this. One is to bring all functions into one large system. This has the benefit of having all information in the same place, and it's easier to achieve a free flow of information. The downside is that this requires a strong existing alignment between the departments, and compromises will need to be made. Another way is to let each department use systems specialized for their needs and facilitate information exchange between the systems through connectors, or APIs. This has the benefit that every department can use systems that are most efficient for them, while also having access to up-to-date information from other departments. It may seem that the best solution would be to have one large system that is optimized for all needs of each department. However, with the fast evolution of software, each system provider needs to specialize to be able to provide the very best functionality for their users. And even if one system could be the best at everything, it would only be a matter of time before another system outperformed it in some aspect, due to it being specialized in that area. This is why it would be my guess that the trend of specialization will continue, and that the best strategy will involve multiple systems connected through the use of APIs. And this is why, in order to create a strategy for combined assurance and system evolution, it's important to have a foundational understanding of what APIs are and how they work. In the next part of this presentation, we will be looking at APIs. Over to you, Mikael.
Thank you. As Linda said, in this part of the presentation, we'll be looking at APIs. We'll look at what they are and how they can be used. Later, we'll look at the TeamMate APIs. To begin with a very short summary, APIs are, essentially, a structured way for computer systems to communicate with each other. In order to see how this works, let's start by looking at how people communicate. When we communicate, we use words and grammar made up of established rules and conventions that form a protocol for how to communicate. Words themselves don't carry meaning, and so in order to understand each other when we communicate, we need to already be familiar with the same language. So in order to communicate, there needs to be some agreement on how to communicate. Computers are clearly different from people in all sorts of ways, but the fundamental challenges of communication are largely the same. Systems can be written in different languages, in different ways, with different goals in mind, and with all sorts of different underlying assumptions. So how can different systems communicate? As with people, there needs to be some agreement on how to communicate. For computers, this agreement on how to communicate can be an API, an application programming interface. We can think of an API as a boundary of a system that tells us how to communicate with the system without knowing anything about how the system works. This is somewhat like buttons on a dashboard. We may know what a button does, but we don't need to know how it does something in order to use it. For instance, on the dashboard of a car, a button might turn on the radio or the air conditioning. We don't need to know how the radio or air conditioning work in order to turn them on using a button. We just need to be familiar with the interface. An analogy for an API can be something like an electrical socket. In order to plug in an appliance into an electrical socket, the power plug and the adapter need to be compatible. They need to follow the same standard. Phrased differently, they need to implement the same interface. Beyond this interface, the systems don't need to know anything about each other. An appliance plugged into an electrical socket doesn't know how the electricity it receives is generated. In a similar way, whoever generates the electricity doesn't know what appliance might be plugged into an electrical socket. As long as there is a shared interface, they are able to communicate without knowing anything about how the other system works. APIs are much the same way. The electrical socket transfers electrical energy. A computer or a system can transfer data using APIs. But the general idea is the same in this respect. A quick note about the word API. When we talk about APIs, we can talk either about a specification or an implementation. If we take the analogy of the electrical socket again, we can say that there exists a specification that describes what a socket should look like. Then there is the actual socket, which implements the specification. One is a blueprint, the other is the actual thing built from the blueprint. When it comes to APIs, both the specification and the implementation are often called APIs. So, on one hand, it's common to hear people talk about what an API looks like in terms of its specification. And it's also common to hear people say things like, you can call our API, in which case they refer to the implementation. Now that we have talked about what APIs are on a high level, let's look at a few examples. We have created a small program that exposes an API to give a few simple examples of how APIs can be used. These APIs are so-called REST or RESTful APIs. There are other types, but this is the most common type today. We're going to be using a program called Postman to call APIs. Postman is a tool that can be used to call APIs manually. Now, generally, the point of an API is to enable communication between systems. However, when developing or demonstrating APIs, it's often useful to be able to call them manually. Postman is one tool we can use to do that. This is Postman. On the left-hand side, we have predefined a number of calls that we can make to our API. These calls are configured manually and can be stored and given a descriptive name. For example, you can see get notes and create a new note. Our first predefined call goes to a small program that lets us store and retrieve notes. Let's start by opening the call to the endpoint that retrieves notes. You can see that there are quite a few settings in Postman. Among other things, you can see that this request uses the verb get and calls a server running on localhost on port 8081. We can also see that the path of the URL we are calling is /note. For an API, this path is called an endpoint. We can call this API by pressing send. When we do, we can see that the server returns 200 OK and a note with some text. 200 is a standardized status code, which means the server successfully returned the request. All codes starting with 200 indicate some form of success. You can see at the bottom of Postman that we got some data from the server. This data is in a format called JSON, JavaScript Object Notation. This is a popular format because it's easily readable both by machines and by people. The format is machine readable because it's structured, and it's readable by people because it's text-based and quite intuitive. You can see that we got a note. It has some text and an ID. Next, we'll create a new note in the system. This time, we will call the same endpoint but with a POST request. By convention, in a REST API, GET retrieves data and POST creates data. This is also how these verbs are implemented by our example program that we call using Postman. This time, we will include a request body in the form of a JSON object. This is a note that we want to create or store in the system. When we press send, the server responds 201 created and returns the note that was created. You can see the text we entered returned by the server, and you can also see that the note was assigned an ID by the server. If we do another GET request to get notes, we will see that this time we also got the note that we added to the system. What we have done is that we have stored and retrieved information using an API. This is one common use case for APIs. Next, we'll try the endpoint we call double. This endpoint multiplies a number by 2. This time, we will include a query parameter in the request. You can see that the parameter num is part of the request and that it has the value 21. When we send this request to the server doubles the number and returns the result, 42. This is a simple example, but it illustrates that in addition to storing and retrieving data, APIs can also be used to process data. A real-world example could be something like calculating premiums for insurance or classifying credit card transactions. Next, we'll look at a more useful example. We recently built an application that needs to verify VAT numbers. To verify VAT numbers, we built a small program, a microservice, that allows us to automatically verify VAT numbers. We will be calling this program manually to demonstrate how it works. First, let's verify the service is running by calling its health endpoint. You can see that we are making a GET request to a local host on port 8080 to the path or endpoint /health/ready. When we press send, the server replies 200 OK and says the status is OK. These types of endpoints can be used to monitor systems. We could also get additional information, for instance, about the number of transactions being processed, CPU usage, and so on. Now, let's use the VAT endpoint. We will call the endpoint /VAT and give it a query variable called full VAT number. That includes a VAT number. When we call this endpoint, the server resolves the VAT number, tells us who it belongs to, and informs us that the VAT number is valid. Behind the scenes, our server retrieves the data about VAT numbers from several different sources. In this case, being a Swedish VAT number, our server gets the information from a service provided by the European Commission called VIES. A Norwegian number, for example, would have been returned from a different source. We can see that a program that exposes an API can, in turn, call other systems to retrieve data. What we have done is that we have called APIs using various parameters and settings that we have manually set in Postman. How do we know what these parameters are supposed to be? What endpoint should we call? What request body does the system expect? How do we authenticate? What data does the endpoint return? And so on. The answer to these questions is that the API needs to be documented. There are many ways of documenting APIs. One of the most popular is to create an open API specification. These are often called Swagger specifications. These specifications can be automatically generated from projects, provided the project is set up in such a way as to allow this. The documentation is then provided in JSON format, which we mentioned before. It can also be displayed by Swagger as a website. TeamMate, of course, has such documentation for the TeamMate APIs. Next, we'll have a look at how they can be used.
Thank you for that. Now that we know what APIs are and how they work, let's have a look at what this looks like in TeamMate. You can find this yourselves by going into the main menu and navigating to Setup, Data Movement, and Data Exchange. This is where you'll find the API Swagger documentation. This is, as Mikael just mentioned, the guide that will help us to tell us which APIs are available and how they work. So the information on this page will allow us to see what is possible to do using the TeamMate API. You will see different keywords here to the left, combined with a path that can be appended to the base URL. This path is called an endpoint and can be called using the keywords to the left. These are also called verbs or methods. These keywords are all standard keywords for REST APIs and indicate the usage of that endpoint. Let's scroll down to the audit plan section. This is a well-structured documentation page that also provides a short description of each API. For example, we can see that in the Get options, we can get a list of all audit plans, a specific audit plan, a list of projects in a specific audit plan, and so on. Looking at the post keywords, we can see that we can add activities directly into an audit plan and add users. We can also patch, meaning change existing information, and delete information. If we click one of these line items, we can see what parameters we need in order to call this particular endpoint, and what information we can expect to get back. This is the information the developer needs to call the API. You may recognize most of these categories, as they are the same ones that you will find in the taxonomy of your TeamMate setup. You may have changed the labels in your own taxonomy, so if you don't recognize the definitions in the Swagger documentation, you can go back to the taxonomy page and see what system label it has. The system label will correspond to the terms used in the Swagger documentation. By scrolling through this list, we can quickly get an overview of the extensive possibilities made available by the TeamMate APIs. Now, let's have a look at a real-life example of an API integration that we have built. This is a smaller project, so we can show you the functionality and what a solution may look like. In this case, the customer did regular updates in Excel to score their some 6,000 risks. The long-term plan was to integrate the systems. But as a step in that direction, they asked if it would be possible to keep updating their scores in Excel and then uploading those scores directly into their risk assessment in TeamMate. It is indeed possible to upload data from Excel to TeamMate using the TeamMate APIs. The data could have been from almost any type of source, for example, other document types and of course other systems with available APIs that we can connect to. What we did is we created a small program that allows them to download and upload data to and from an Excel sheet. By clicking Export to Excel, the customer can use their spreadsheet to continue updating their risk scores in Excel as they were used to. But instead of then updating these risks manually using the risk sliders in the risk assessment, they can upload all their 6,000 risks and have them updated at once. Let's have a quick look at that application. This is what the application looks like from the user's perspective. The interface can be opened in a web browser, but in this case, it runs from my own machine, as you can see in the URL reference to localhost 8082. For the purpose of today's demo, we have created a risk assessment with 2 risks. The number of risks doesn't matter, however, and the amount of risks can be as many as needed. We have created a custom perspective that also shows the system ID for clarity. As you can see, we have a strategic risk called financial risk. It is now currently scored with a high inherent probability of 10, giving it an inherent risk scoring of 8, which is considered critical or red in this organization. I will now use the Excel uploader to change this to a 2, bringing the inherent score down to green. To get an Excel sheet with the current risks and risk scorings from TeamMate, I click the Export button to my left. This gives me a downloaded Excel file with all the information needed. I can now simply update my inherent probability score from 10 to 2, and then save it. Next, I will go back to the application and simply drag and drop the updated file. This will trigger the application to start the process. To my left, I can see the status of the upload. It is important to see the current status of each step to be able to make any corrections if something were to go wrong. For example, if I gave risk number 5392 a letter instead of a number, I want to easily find the problem and correct it instead of spending time on looking for the problem. I can now see that the file was received, validated, and the risks were updated and the progress completed successfully. If I go back to the risk assessment and update, I can now see that a previously red risk is now updated to green. This concludes our demonstration of what APIs are and how they can be used. Next, let's have a look at some common challenges and suggestions for how to build TeamMate integrations and software in general. Let's start with step 1 in every project: clear goals. This may sound obvious, but a surprising amount of projects go ahead either without a clear goal or perhaps only with a high-level goal, and without a clear understanding of how to reach that goal. A common misconception is that agile projects do not need goals or even planning. I would claim the opposite. Working agile, working iteratively, helps us minimize the cost of going in the wrong direction by redirecting often, but we still need a goal to redirect towards and an efficient mechanism to check our direction and make decisions along the way. So, to look at an example, let's say the project owner of a team, given the high-level goal to build a transport vehicle, describes a car to the team, and the developers start building. Everyone is confident that they can deliver the car in time, and everyone agrees on the goal to build a transport vehicle. But a few months in, after a prototype starts to take form and is being demonstrated, it turns out that some stakeholders actually wanted a motorcycle, and others were thinking of a boat. This happens far more often than any company likes to admit. We can't say for certain, but we suspect that clarity of goals may be especially challenging for IT projects. If we build something like a car, it's easy to visualize the end result. Software is somewhat intangible. We interact with it through user interface, but most of it is hidden from view and therefore somewhat obscure. So, to reiterate, before we can do anything, we need to decide what we want to achieve. Different people may want different things, and that's okay, but we need to know this as soon as possible. The clearer the path to the goal, the better we can plan and estimate costs and resources. So how do we set meaningful goals for IT projects? We believe that the key to this is to involve IT early. We often see that organizations eagerly start working on ideas and concepts without consulting IT in the early stages, thinking it's best to involve IT once the ideas have been finalized. Often it's discovered when the project is handed over to IT that parts of the concept may not actually work, or the intent may be unclear. But since IT is now considered responsible for implementation, the stakeholders are often no longer available on short notice for follow-up questions, and the developers are left to figure out things for themselves. By bringing in someone with expertise in the area, such as vehicles in our example, the expert can ask the right questions and map out what it is that each stakeholder wants. Perhaps it turns out that the stakeholders in fact wanted was not necessarily a truck, a boat, and a motorcycle, but in fact they needed cargo capacity, water transport, and speed. By asking the right questions and understanding the limitations of the available vehicle types, the expert can map out the different stakeholder expectations and suggest what requirements can be combined and what requirements are so different that any solution will require major compromises. That way, the organization can make an informed decision about what end goal is most appropriate to meet the objectives, or even split the projects into two solutions. Before an implementation can work, the idea has to work conceptually. Let's take an example. So one real-life example is a project where the goal was to consolidate reporting of compliance risks. After a while, it was discovered that the first-line risk managers and the compliance officers had very different ideas of the definition of compliance risk. Compliance officers defined it as the risk of being in breach of a regulation, while the first line defined it as the risk of being fined for that breach. This gave very different results in the risk scoring. This is a conceptual problem that has to be resolved before any solution can be built by IT. Another example is when two departments scored the same risks very differently, and they couldn't agree upon any compromises. It wasn't until they brought in outside consultants that they realized that while they did use the same scale of 1 to 5, one department defined that 1 as high risk and 5 as low, and the other department defined it as the opposite. This is yet another example of a non-technical question that may need to be addressed before the technical design of a solution can be created. Of course, when building new things, the path can never be completely known since we are creating the path and heading into new territory. But the more we know about how to get somewhere, the better we are able to plan. So how do we make sure to stay on track?
Once we have started a project, how do we know we're on the right path? In most cases, the best way is to involve users early. The more feedback we get, the better we will be able to correct our direction. The more often we get feedback, the sooner we gain insight into the accuracy of our assumptions, and the sooner we can direct our efforts towards meaningful improvement. In IT, we tend to call some version of this agile software development. It also sounds a lot like the scientific method. We start with a hypothesis. For instance, we believe our employees would love an application that matches people with random lunch buddies. We test the idea by conducting an experiment, for instance, by building a prototype and doing hallway testing with our colleagues. Then we analyze the results and iterate. Once we have the results, we need to decide how to proceed. This brings us to our next important point. Clarity in roles and responsibilities. If we want to be able to direct our efforts in a meaningful way, it's important for someone with an understanding of the goal and the project to have both the responsibility and the authority to decide how to proceed in each iteration so that the project can keep moving and move in the right direction. It's common for organizations to have stakeholders with overlapping roles and responsibilities. This can easily lead to a lack of clarity about who decides what. Let's take an example. Say a company works in Scrum. The product owner of a Scrum team tries to figure out what to build and speaks with several stakeholders. It turns out they all want different things. Who decides how to proceed? In theory, it could be the product owner. However, frequently, the product owner builds things used by the stakeholders and has to cater to their interests. As a result, the stakeholders de facto have a final say in what to build. In the resulting situation, the stakeholders are, in some sense, the product owners, and the person with the title product owner ends up functioning as a proxy, passing messages between stakeholders and developers. If the stakeholders are not communicating or are not in agreement, the result can be a stalemate, where developers ask the product owner what to build, and the product owner is unable to answer because the stakeholders give different messages. The solution is simple. It needs to be absolutely clear who decides what. The faster we can make meaningful decisions, the faster we can iterate, and the less time we have to spend waiting for decisions. This is a challenging role. Whoever has such a role needs to be able to balance interests and get internal support for a balanced solution. Once we start building, unless we are a startup or are building prototypes, we should generally prioritize quality in favor of speed of development. The reason is that software will often run and be maintained for much longer than it takes to write. A program that takes weeks to write may run for years, and it will likely need to be maintained for all of those years. So the maintenance cost of software can be many times the initial build cost. To illustrate this, there are companies that have won contracts by offering to build software for free, provided that they will then be in charge of changes and maintenance. Of course, these companies are making healthy profits, so we understand that maintenance costs can be considerable. If a program is complex, it will be difficult to find people who are able to maintain it, and maintenance is likely to be time-consuming. If a program is clear and simple, maintenance can be quick and easy. Prioritize quality. This brings us to our next point. What is quality? Well, that's a big question, but let's look at one major aspect. Software is complicated. Our job is to make it as simple as possible. There's a quote by the famous computer scientist Tony Hoare that I think is a great description of the importance of simplicity. I conclude that there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. The first method is far more difficult. I think this quote is a great summary of many of the challenges of designing software. Let's elaborate a little bit. Any problem has a certain amount of complexity that is essential to the problem. Any solution to a problem will never be less complex than this essential or inherent complexity. However, all solutions will also add a certain amount of complexity that comes not from the problem itself, but that is from the solution or the implementation of the solution. The less complexity we add, the better. Different solutions may appear the same in terms of the result, but simpler solutions are easier to maintain and are likely to be more reliable. Therefore, simplicity should be a highly prioritized goal when aiming for quality.
So, looking at what we just learned, our advice to achieve success with your API integration project, or in fact any software development project, is to have clear goals, involve IT early, involve users early, have clarity in roles and responsibilities, prioritize quality, and keep it simple. Based on this, we have developed a model for API integration projects. As in any project, we will start with an initial meeting. This gives us a high-level understanding of the goal and helps us determine if the goal is feasible and if it is something we can deliver. If we decide to proceed with the project, we move on to the discovery phase. This phase is key to success. In this phase, we use an iterative method with early involvement from both IT and the user side to formulate a clear goal for the project. This is also the phase where we start constructing the high-level design of what the end product may look like and start identifying what needs to be done in order to build its solution. It may be anything from methodology alignment to deciding on hosting for the solution. Once we have defined the goal, we can start identifying the stakeholders for the project and what is needed in terms of resources to reach that goal. This discussion is often focused on the cost for outside consultants, but we believe it's also important to early on have a clear understanding of what is needed in terms of time from stakeholders, user testing, and internal discussions for decision-making along the way. For larger projects, the discovery phase would be treated as a project in itself, resulting in a report outlining the goal, the stakeholders, and an estimation of resources needed to build a solution. This makes it easy for the organization to decide if the project should go ahead and when to plan it. During the build phase, or delivery phase, we work agile to build a solution in close cooperation with the end users. By building the solution in small steps with frequent testing, we can ensure to have a solution that will reach the goal set out in the discovery phase that is also user-friendly. We make sure to work with the clean code policy to ensure easy maintenance of the software going forward. If we were to discover along the way that there is a reason to adapt the goal of the project, we may iterate and reopen the discovery phase to adjust this direction. Finally, after the project is completed, we do a handover phase to ensure the organization has all information necessary for the future. The documentation consists of a detailed design, the reasoning behind the decisions made, and technical documentation so that in-house developers are able to take over maintenance if this is required. This way, we are able to ensure that the project stays on track and connected from start to finish, avoiding these common pitfalls of software projects. Now, let's take a step back and look at what we have discussed today. The internal audit profession is rapidly changing due to a number of factors that are driving rising stakeholder expectations. To be able to meet these challenges and meet these rising stakeholder expectations, it is of utmost importance that all internal auditors, regardless of department size, develops and implements a digital strategy. Perhaps the best way to do this is by letting each department select the software solutions that best suit their needs and enable communication, cooperation, and collaboration through the use of APIs. This will make sure that each department gets the support they need from the best solutions available, and that it is possible for them to change systems as the rapid development continues and new technologies emerge. To be able to understand the possibilities and build such a strategy, it is important to know what APIs are and how they can be used. In essence, APIs are connectors that enable systems to exchange information. This enables a free flow of information through the systems in an organization and makes the information available where it is needed. When initiating an API integration project, it is important to be mindful of the common pitfalls of software development. Such a project requires a close cooperation between business and IT to be successful. All stakeholder needs must be taken into consideration and prioritized. Questions that may arise span from anything from methodology changes to technological setup challenges. To manage such a project properly, you may consider using a 4-step model to outline the different phases and ensure the project stays on track. Each of these topics could have easily been expanded into its own presentation. For now, we hope that this overview has proven valuable to you. Our hope is that this presentation gives you the information you need to start discussing your own digital strategy, and that you are now familiar with the terminology and the options available. We also hope that by sharing our experiences, you are able to avoid some common pitfalls and achieve a successful outcome of your project. If you have any questions regarding the use of APIs, how to develop your own technical strategy, or about software development in general, please feel free to contact us. You can also follow us on LinkedIn, where we publish articles, blog posts, and videos about technological development from different angles. Now we will answer your questions live. Thank you for listening.